Okay, this screencast is going to be for solving systems of equations using tables and graphs, and I'm going to show you how to do it on the calculator. So if we follow the cursor, the first system of equations we're going to work with is right over here. Y equals 2x plus 3, and then the second equation, negative 3x plus 8 is equal to y. So on your calculator, you want to click in your y equals menu, and then type in your two equations. So we have 2x plus 3, and then even though the second equation, even though it's negative 3x plus 8 is equal to y, we can also say y equals 8 plus negative 3x, or negative 3x plus 8. So this that we can put in y2 can be negative 3x plus 8. And then if we push graph, we can wait for the lines to be drawn, and then there's a nice intersection point. Can't really tell, are we 100% sure if it's at 1? Maybe, maybe not. So we push second trace, and that takes us to calculate. And we want to find the intersection point, so we push 5. Our first curve is going to be our first line, so make sure it says y1, and then you push enter. Your second line should be y2, and then you push enter. And then your calculator prompts you with a guess. Do you want it to guess the intersection? Yes, you do. So push enter. And you wait, and it says the intersection is where x is 1 and y is 5. And if you're looking in the table, you look in your y columns, so here and here, and you want to scroll up and down. Here we don't have to scroll until we see both y's equal to the same number. So this was a nice example. We pushed graph, got both lines on the graph right away, saw the intersection right away. Well, what happens if it's a little bit more complicated than that? So here is an example. The slopes are fractions, maybe something you don't want to deal with, something you're thinking about, all right, I'm not going to do substitution, not going to do elimination, definitely want to do this one in the calculator. So we have to put it in. So what I like to do is put the slope in parentheses, so I'm not messing anything up. 1/2 x plus 6, and then the other one is negative 2/3 x minus 8. So if I push graph on this one, there's my first line, there's my second line. So unfortunately, I can't see the intersection point. So I can't use the graph. So that's why I want to look ahead at the table. So I push table, and my numbers are all over the place. Holy cow. Okay. They're 14 apart here. They're 17.5 apart here. They are 21 apart here. So that means if I were to scroll down and make my x's increase, I'm going to get farther away. So I'm not looking for a high x. And if I look at the graph, here's my x-axis, here's the y-axis, and the intersection point is back here. I go all the way to negative 10. So I want to look somewhere lower than negative 10 in my table. So I can go to second table set, and then I can have my table start at negative 10, even though I know I'm going to be going farther down than negative 10. Then I go back into my table. I'm going to scroll up, and I'm looking, and there it is. At negative 12, both of my y values are 0. So I can come into my window. I can keep my y values the same. They can go from negative 10 to positive 10. But it's these x's that I want to change. Maybe my x minimum should be negative 15, and my x maximum should be 5. So I'm still having 20 units across the x-axis, but I hopefully should be able to see the intersection point. So go back to the graph. No second. So just push graph. And there it is, the intersection point right there. And again, second, calculate. I'm looking for the intersection My first curve is y1, so I push enter. Second curve, y2, so I push enter. Do I want it to guess? Yes, I do, so I push enter. And it calculates the intersection point. X is -12, y is 0.